Almost had that time. Give it one more try. That's all right. Come on. Luckily, we got plenty of time here, guys. All right. Bang, 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 bang. Close. Almost made it.
There's a lot of questions in this review.
Good practice is lots of practice. All right, so let's check this out. So this is a chemical formula that, if you balance it out, actually it's that. This is what causes transition lenses to work. Silver chloride and copper by themselves are clear, okay? But silver by itself gives a tint. And so when you walk outside, what do you increase? What on the board? It's a reversible reaction, so you need both directions. When you walk outside, what on the board increases when you walk outside?
Energy.
Energy. So when energy increases, so energy increases, which way does this reaction shift?
That way.
Exactly. You shift the reaction to the right, causes the glasses to get dark. Okay? Whereas when you walk back inside, energy decreases. And that's going to cause the reaction to shift back towards the energy. Okay? So looking left or right, as I ask the question, I'm looking for left or right from everybody. It's pretty straightforward. Mr. Salibi says if anybody has trouble teaching or learning this, that he teaches the pencil method. Okay? So what you do is you hold a pencil up in front of you, and if something gets added, you add it to that side, and then what do you need to, which way do I need to shift to make it balance again? To the right. If something gets taken away, I need to shift to the left. Make sense? Okay? I've never thought about it like that, but some people it helps. And like I said, Mr. Salibi likes to think of it like that. So let's go through everybody and let's see if we can talk about shifts. Okay? Josh, which way are we shifting if you add Ag, add silver? All right, where is silver? By itself. It's on the right. So if I add it to the right, it's going to shift the reaction to the left. If you use the pencil method there, if you add to this side, you need to shift to the left to make it bounce again. If you add, it shifts it away. It pushes it away. If you take away, it pulls it towards. Make sense? Okay. Daniela, what's going to happen if I take away copper? Left or right? Take it away, it's going to shift it towards. You take away the copper over here by itself, it's going to shift it back towards it to replace it. You with me? Moving to Nyla. All right. Josh, Josh, you ready? Okay. What about if I add copper? Which way we shift it?
To the right.
Okay, Styron took your question. I'll come back to you. You're fine. You're fine.
Oh, no.
Okay. So Styron's got it. Josh, ready? What about if I add silver chloride? If I add AgCl3, which way we shift it? Yeah. On the left. Add it to that side. We're going to shift it to the right to balance out. Cool. Okay. Ready, TJ? All right, what about if I take away copper chloride, CuCl3? If I take away CuCl3, which way we shift it? Wow. Boy, you flipping coins out here, see? Look, ain't no need to flip a coin. Do what you need to do. Which side is CuCl3 on? The right or the left? CuCl3, which side is it on? Very good. And if you take it away, Will you want to get more of it, or will you want to, do you have plenty of it? Take it away. You want to get more of it, so we need to shift towards it, which would be shifting towards. If you take it away, you shift towards. If you add, you shift away. Got me? Okay, Matthew, you ready? What about if I add energy? Shifting right or left if I add energy? Right. Yeah, it's on the board. I can't be easy with it. If you're missing days, I look out for you. Feel good? I was finished. Are you ready? You ready? Okay. Ready, Ashley? What happens if I add copper? If I add copper, which way we shift it? Copper's on the right or the left? Copper by itself. Copper Cu. Cu by itself. The Cu on the right is copper chloride. The Cu on the left is copper. So if I add copper, which way we shift it? Very good. You add something, you shift to the other side. If you take it away, you shift towards it. Martin, you ready to finish this off? What happens if I take away silver? Silver is Ag.
Silver is by itself on the right.
Silver's by itself on the right. If I take it away, which way we shift it?
Left.
If you take it away, you need to replace it. So if I remove silver, I'm going to shift to the right to replace it.
Right.
If you take it away, you shift towards it. If you add it, you shift away from it. Okay? Need to do another example? All right, let's do a couple more with the one we did yesterday. The one we did yesterday about the eggshells. All right, if I breathe on it, which way we shift it? If you breathe on it, what are we adding?
To the right.
We're not adding energy, what are we adding?
Carbon dioxide.
We're adding carbon dioxide. If you add carbon dioxide, you shift away from it, which is to the right. Everybody feel good? Okay. What about if I start removing all of the eggshells from this reaction? That's the CaCO3, the calcium carbonate. I start pulling all the calcium carbonate out as fast as I can. Which way we shift it?
Right.
To the right again. Yeah. Feel good? All right, guys. So you got about 4 questions that deal with that are just 50-50 shot questions, but don't just flip a coin. Even though they're 50-50 shot questions, that just means you have 2 options. It doesn't mean you flip a coin. It means you pick the correct one. If you add, you shift away. If you remove, you shift towards it.
That's the test tomorrow.
That's the first 4 questions on the test tomorrow. All right, the next 5, 10 questions on the test tomorrow have to do with, is it an acid or is it a base? Okay, so I'm gonna put you out. Well, I ain't done so far. Yeah, so far. There's just 14 questions that aren't math. Then you got 2 math questions. So 14 questions that aren't math, and then 2 math questions. Okay, and we'll deal with the math questions after we deal with these, because all of these questions are: is it an acid or is it a base? All right, so I'm going to write down what it is, and I'm going to have you tell me which way to shift it, and we'll go down the line just like we did. We started over here that time, so we'll start with Martin this time. All right? Let's do a different color. Martin.
Yes.
Sour. Which side's it going on?
Acid.
Very good. All right, keeping it rolling. Ashley. It gives you lots of H's. If it gives you lots of H's, are we talking acid or are we talking base?
Acid.
Very good. Okay. Matthew? Uh-oh. I'll be glad to open it for you. Matthew, bitter, which side's it going on? Tasting bitter. Anybody want to tasting bitter like something? Somebody help them out. Without saying the answer, what does it taste bitter like? Bitter like soap. Which way are we going? Very good. Bitter like soap. All right. Mr. Styron. How about gives you OHs? Very good. If it has OHs, it's a base. If it has H's, it's an acid. Feel good? So HCl would be hydrochloric acid. NaOH, base. Okay, KOH, sodium hydroxide. Very good. KOH is a base. How about HClO3? Acid. Yep, absolutely. Good job. All right, keeping it rolling. Now these we hadn't talked about yet, but maybe you know them and it'll help you out tomorrow. Okay. Litmus paper is paper that you can put into. Now, usually if you put in paper in a pool or something, you actually don't use litmus paper. You use pH paper. And so you have a paper and it changes color and you compare the color with the little thing on the box that it comes in. pH paper has all kinds of indicators. Litmus is just one indicator, and it just gives you a 50-50 shot. It just changes color based on whether we're talking acid or base. So I'm going to do the different colors. If your litmus is red, anybody, we thinking acid or base?
Acid.
Very good. It's easy to remember because if your litmus is blue, it's an alliteration. You know what alliteration is?
A bunch of words starting with the
Same word that starts with the same letter.
Excellent. Good job, guys. So we're talking like Peter Piper, Pickle, Pickle,
Yeah,
Pecker.
that thing.
Okay. And anybody know what? This is not chemistry, but we just do a real quick one. What's the word if it's a bunch of vowels? Like, an example would be, in Ireland, I initiated an igloo.
Huh? What?
Like, alliteration is consonants. Peter Piper, Peckle, Pickers. Okay. If you do the same thing with a bunch of vowels, anybody know what it is? Very good. Go ahead, Tanala, and called an assonance. Very good. Okay. If litmus is blue, it's an alliteration. Blue means base. Okay. So that's got an easy one there for us. Okay. Yesterday we talked about a neutralization reaction. A neutralization reaction happened when you put an acid with a what?
A base.
Very good. So if I say reacts with a base, what's the answer?
Neutral.
If I say reacts with a base, what's the answer?
Acid.
Acid. If I say reacts with an acid,
Base.
feel good? That's an easy one there. Okay. We talked about H's, we talked about OH's. Let's do pH. Okay, where we at? We got styrene, so we need to get over here. TJ, give me a pH if something has a pH of 2. Where are you putting it? Okay, before you answer, where could you find a pH of 2 in this class? Help them out. Nah, not the water. We would have to do some surgery.
Oh, it's in the closet?
Nah, not going to call it. We have to do some surgery.
It's in the cells.
Now your blood's actually 7.35.
Is it the acid in our stomach?
Cheating, you gave the answer,
Oh.
but in your
Stomach.
stomach, so it's a
Acid.
acid. Okay, what's my magic number?
7.
And what would 7 be?
Base.
Perfectly neutral. Okay, which means if you had an 11, where would it be?
Base.
What about 7.1?
Base.
Base. What about 6.99?
Acid.
Feel good? Okay, what's the highest number you can go?
14.
14, lowest number?
1. Actually, you can get 0.
You got below 1.
Well, you
You know, you have an acid, yeah.
0 point something.
0, you can never really get to 0, you can never get to 14. Okay? What type of measurements are these? What was the word we used? Anybody remember?
Shoot.
Nah, not shoot.
Stay.
Here's the way you remember it. Kind of like Celsius. Celsius is
Kelvin. I don't know why I said that.
You look at the temperature on the what?
Scale.
On the scale. It's a scale measurement, which means that is 4 2 times stronger than 2?
No.
No. It's actually 2 would be 100 times stronger than 4.
4 and 3 times.
Because it's a scale measurement. It's a number that takes really, really weird numbers, these 2.3 times 10 to the negative 3, and makes them usable numbers. 2.7. Make sense? Just like you don't want to say it's 293K in here, because that sounds weird. Is it 293K in here?
No.
It is. Because what's 293K? Nah. Well, 70 degrees what? Fahrenheit, but 293K is. Nah, come on, do the math. What's the magic number? Nah, close. 273. 293 minus 273 is 20 degrees Celsius is room temperature. Yeah, cool.
Isn't that room temperature like 58?
Sure. Depends on how cold you like your house. Okay. Any questions on what's an acid, what's a base? We going 100 on that? Okay. So the only thing we have left is these guys over here. Okay. Well, it shouldn't be. So let's do some examples. All right. You have a hydroxide ion concentration of 2.7 times 10 to the negative 4. I want to know, is it an acid or a base? Josh, what can I do? What's up?
Don't you have OH?
I do have OH. So where can I change that to? I can change it to POH. What's my formula? Can somebody hook me up? Tonight I see you pushing buttons already. Ashley, can you do it too? Double check behind her. Thank you. How do you do it? You ready? Everybody got your calculator? Go ahead, Matthew, because you need this. Go grab that calculator. Okay, everybody ready? Negative. Log, where's the log? Right below the second. So negative log. That starts your parentheses, and then just type it in just like this. 2.7 E negative 4. Ma'am? 5.6. What's after 6? So 7? I think that's what you said to start with, isn't it? Good job.
A negative 4?
2.7 times E negative 4. Yep. Let's double check, make sure everybody agrees with her. You agree, Josh? All right, well, let's see what we're doing here. Ashley? Matthew? What do you got?
I got like 370. Let me redo it.
What you got? What? Which same thing? There's like 3 answers. What's your screen? How about Josh over here?
3.5.
Well, we got some disagreement. All right. Go ahead, talk tonight. Hey, that shouldn't make a difference.
Mine was science too.
All right, we'll have to look at the calculator screen. Let's see what you got. That looks good. Let's see what you got. What did you say? 5.7.
I got 3.56.
You're fine. You're fine. So 3.6. Okay. So 3.6 is my what? Josh, you told me what we're doing. 3.6 is my what? 3.6 is my POH. Now we don't have a POH scale, so what do we got to do? And it's one of the easiest formulas you're ever going to do. What is it?
14 minus 3.6. It's 10.4.
I agree. Somebody double check. Answer my question. Very good, because 10.6 is, or 10.4 is, woo, how we feel?
Good.
Okay, one more example, and then I'm gonna set you free to practice. All right, let's do a little bit easier one. All right, actually, I was about to say we'll do the same one. But yeah, we can do the same one. Let's do the same one. Let's use my 10.4 pH. My 10.4 pH, I want to know how much hydrogen do I got? What's my formula?
The 10 to your negative
Yeah,
pH.
it's the opposite of the line. 10 to the negative hooks me up. So I'm going to say 10 to the negative 10.4. Now, there's a couple different ways you can do this. You can hit the caret button on your calculator, which is the button that looks like this. You can type it in like this, 10 to the negative 10.4. Or, if you want to save yourself a keystroke, you can hit just second log, which second log gives you something that looks like this. All in one button. And then you just type in negative 10.4. Either way, you'll come up with the same answer.
3.98.
Syntax error.
4.
Syntax error means you're typing in something wrong somewhere, buddy.
It's 4.
No. Give me some decimals. I like this.
3.98.
10 to the 11, negative 11.
Yeah.
All right, now, let's look back. Like I said, a trick that you can do to make sure that you did it right is that this exponent should always add up to 15 when compared to that exponent. Did it work?
Yes.
11 plus 4 is definitely 15. Like I said, guys, this is easy peasy lemon squeezy tomorrow. Okay, questions, problems, thoughts? And I'll be honest with you, this is one of the things where a lot of things we do in chemistry, I'll be honest with you, you're probably not going to see again for a long time, unless you do something medical or something in chemistry or things like that. This is one of the things that can stick with you, man. This is, how acids and bases work. This is in cooking. This is in keeping your pool straight. This is in keeping your medicine balanced when you're dealing with certain things. All kinds of reasons to keep this in your mind and understand what's going on. Yes, sir.
How long do we have to do the thing on the spreadsheet?
Same problem. You got time? Any other questions? All right, so practice is up there. I'm gonna let you flip gears and go ahead and get started. A bunch of you got more stuff than that. So get to it. I'll come around, make sure you're rocking and rolling. All right, I'll get you. Just hold on to it, I'll get it. That is from today. That's today's practice.
Mondays. Tuesdays, sorry.
I'm talking to him.
No, it's Tuesday, Thursday. I gotta do it too.
Can we do them on paper?
The review, let me see the review. I'll be honest with you, I hadn't looked at it. Let me look at it. You can do it however you want to. If you're gonna do it on paper, that's fine. Oh, it's no more than what we just did. Because a bunch of these questions are going to be just real quick little questions. And if you need to look something up, look something up. And there's a couple of those words, like we didn't really talk about titrations and buffers, but feel free to look them up and that'll keep you straight. I'm going to finish this video and I need to edit a little bit because I was screwing up my thing at the beginning.